Thank you. Thanks everyone for sticking around for the absolutely last talk of the day. So hopefully everybody's gotten a lot of good information today, and hopefully we'll continue that trend. So as Christine mentioned, Lisa Watts and I will be talking about OpenXR, and she'll be talking about what OpenXR means and how Magic Leap will be using OpenXR as well. So on the agenda for today, I'll talk a little bit about what OpenXR is, why we needed a new standard, or relatively new standard, what we've been working on over the past few years, and then Lisa will talk about Magic Leap and their use of OpenXR, and then we'll talk about what's going on next. So what is OpenXR? So OpenXR is a royalty-free open standard that provides high-performance access to augmented reality and virtual reality devices, collectively known as XR devices. OpenXR is the link between these XR applications and the underlying platforms. They handle the communications between the applications and the devices. An XR platform will provide the application information such as the head and hand position, information about the controllers and the input state, such as whether a button has been pressed or released, and also display configuration and form factor configuration, such as whether there's a single display or multiple displays. The application will provide the underlying XR platform an image or images to display, the audio, and also any haptic responses, such as vibrational responses to the controllers. So why was OpenXR needed? So if you just consider the variety of XR platforms available today, they range in display capability, tracking capability, environmental input capabilities, as well as controller style and input mechanisms. Before OpenXR, with so many platforms driven by proprietary software interfaces, it would increase development time and the cost for application developers to try to reach a broad XR audience. Separate paths had to be developed in the applications for every platform that the developer wanted to release on. This would result in some titles appearing on one platform before another, or maybe even avoiding some platforms altogether. This fragmentation also increases testing. You have to test on all the individual headsets, and each of these paths would be different, so you might find bugs that were on one path and not the other. So, all of this would increase the time and effort required to develop one title across multiple platforms. With the development of OpenXR, application developers can now program to a single common high-performance API, which supports all the major VR platforms and many of the AR platforms that are out there today. OpenXR is also an extremely flexible API. It supports both AR and VR devices. It supports devices that are tethered as well as all-in-one standalone devices. And it also supports devices that are running on different OSs, such as Android and Windows. So this is a high-level overview of a possible OpenXR application. It's just to give an example of the flow of the program and the steps involved. I don't have time to get involved today, so it's a very, very brief tutorial in 20 minutes. So I encourage you to check out our GitHub repository and some of the member company sites to get an understanding of where to start from and how to develop an application. And I'll give all of these links at the end of the talk. Another good overview of the OpenXR API can be found in our reference guide, which shows the flow of an OpenXR application and where typically different function calls are used. And this is off of the openxr.org site as well. So let's talk a little bit about some of the latest developments in the OpenXR ecosystem. So we're continuing to accelerate our growth and get on more and more platforms. We began development in early 2017, and 2 years later, we released the 1.0 specification at SIGGRAPH after a lot of developer and community feedback that we'd been given from a provisional release. And then 2 years ago, we released the Conformance Suite and launched the Adopters Program, and that's where we started to see a lot of the devices start picking up OpenXR. And as we saw more and more platforms take up OpenXR, we're also starting to see more and more applications develop and take advantage of OpenXR. If you were at the previous talk, you saw MRTK, as they're moving to 3.0, are taking advantage of OpenXR as well. So kind of where do we stand today? So we have wide support across a lot of different devices. We have support on the Microsoft platforms, both their AR devices such as HoloLens 2, as well as their Windows mixed reality headsets. We also are supported by Meta on the Quest 2, Quest 2, and the Rift S devices. HTC has support for OpenXR across many of their devices and their Vive Wave runtime. Valve supports it across all of the devices plugged in through Steam VR. Mario supports it on all their mixed reality headsets, and Monado actually is an open source implementation of OpenXR provided by Collabra. And if you've seen a lot of discussions today from Qualcomm, the Snapdragon Spaces XR development platform also takes advantage of OpenXR. So speaking of adoption, I'll hand it over to Lisa, and she can talk a little bit about what Magic Leap sees in OpenXR.
Yeah, thank you so much, Brett. So one of the things that obviously Magic Leap has learned with between Magic Leap 1 and Magic Leap 2 is really the challenge of the walled garden versus the more open and interoperable infrastructures. So what we've seen time and time again is that really the strongest area of growth is coming from industries that favor open and interoperability. And as we're working through our new product coming to market, and we hope you guys will all stop by and check it out. This has become a core principle for Magic Leap here in this Magic Leap 2 timeframe. And so we made a complete shift thanks to Jade here, and Jade Muskell here in the room. You guys can check out his keynote tomorrow morning. He's going to talk to you more about the platform overall. There's been a whole team, himself included, that have been driving to really open up the platform and make it based on AOSP, which I think we see as quite standard across the environment, and try to really support open standards overall. So as we take a look at that, the ability to open up the platform, really provide the opportunity for the ecosystem, this has really become a core principle for us. So we believe that in that open environment, the best devices will win. So it is my opportunity to be up here to tout Magic Leap 2 a little bit. So I will take the shameless plug. But as we're taking a look at trying to deliver one of the best devices into enterprise possible, increasing our field of view, making it smaller, lighter, more work ready. That open platform we think is going to be key to unlocking the innovation across the ecosystem for all of you devs out there that are really developing for this platform. Now, I don't know if this is, Jade will talk a little bit more about this tomorrow, but one of the things we're also doing is we are really trying to enable the ecosystem and get out of the way. So the device will run against any cloud infrastructure, run anywhere, local. Data is all protected and owned by the device owners. So these are very important things for Magic Leap to deliver to the ecosystem and to our enterprise partners. So, when we talk about, what are we doing, at Magic Leap to raise the bar, and the Khronos group obviously has been very dedicated to bring the industry together to do the work on interoperability for a long time. And when I was at Intel with Brent, we were, he was, leading even at that time, and so it's great to kind of be back together. So the working group has obviously demonstrated over time that it understands that it is not just about meeting minimum thresholds, but actually about pushing the category. So it's not just about what can we do on a min-bar basis, but giving the opportunity for people to differentiate and innovate and monetize as well. So I think that's a really balanced approach that device manufacturers like ourselves that are trying to bring differentiated capabilities to the world have that opportunity as well. So we're not just all trying to go to the lowest common denominator all the time, right? So I think that's going to be very, very key for us to be able to differentiate what can you do in VR and what is different about AR that we also need to support in the standards and unlock that. And the size of the physical world space, the brightness of that. The fact that you are in the real world and need content to persist and exist, in all of those different scenarios, is unique to AR, and it's something that we're going to be continuing, with our own members at the Khronos Group to continue to drive in this area. So we're here really today to announce and reaffirm to all of you and to the entire industry our support for open standards and making our platform very easy to develop for, lowering the barriers to entry. If there's areas where you think we should be improving, that you need our help further unlocking, please let us know. We will be there to really make that happen. So in that regard, I do have actually a sign of life. Do you guys want to see it? Yeah, okay, very cool. So if you want to watch the video, this is actually working. This is a open GLES render as backend, but we also have it working on Vulkan as well. So if you can roll the video, if you guys have that, click one more time. It's my opportunity. No, it's like that was not the right move. So I don't know if you guys can go back for me and see if that video will play. If not, I'll have to show you guys afterwards. It does work. Oh, there we go. I don't know. I'm excited about this. Maybe I'm just a geek, but I was like, it's working. So, let's give the team an applause. I mean, this is pretty awesome. We will record that and take that back to them. So we are coding in the open right now as part of our early access program. So if you want to come along for the ride, the developer kits will be for sale very soon. We will have early access to the more full support for OpenXR towards the end of the year, and then we're Khronos conformant early 2023. That's the goal. So I'm very, very excited. This is a great moment commitment. So again, if you want to join the program, here is the a QR code for you to scan. Stop by our booth. We have our entire developer relations team is here. Some of them are probably sprinkled around. Some of you may have been a Christian session earlier. We were talking about developing for the platform. So I just want to thank Brent for giving us the opportunity to reaffirm our support to you, the industry, and here publicly in this session.
Okay, I'll give you all another few seconds to check out the QR code. Okay, as Lisa just talked about, we'll soon have another member up on the board for widespread industry adoption, so that's awesome. So that's great news. Speaking of continued adoption, so I wanted to let everyone know that Vario has come out with their Reality Cloud infrastructure as well. So this is enabling using OpenXR in the cloud. So you can use the rendering performance on an edge server and enable a really lightweight headset as well. So this is being done across the cloud, and you can be teleported with your coworkers virtually. So it's pretty cool. So check that out off of Vario's site. And I think they're here as well, so you can talk to them about that. Also want to talk about the game engine adoption. So what's new since I spoke last year on OpenXR is Godot is now integrated OpenXR support as well. So now we have support across Unreal, Unity, and Godot. And then applications for VR support, we have Minecraft and the Flight Simulator from Microsoft. We also have support in Blender for VR scene inspection, and we're also used as the underlying support in the browsers for supporting WebXR. So the Chromium-based browsers such as Google Chrome and Microsoft Edge all use OpenXR underneath to support WebXR. And just to give a shot here of using scene inspection in Blender, so you can walk around your scene and check it out. Obviously, putting on a headset and checking it out as well. And also our latest OpenXR game. So we talked we talked a little bit about this at GDC with XR Games. They released this title, Zombieland VR, which used a single executable that was deployed across multiple platforms built in Unity. So it's really using all of the features of OpenXR. And what was cool about this, and I didn't even know this until the GDC talk, is they said they had deployed this across 27 different VR headsets, which is just amazing. So Hopefully, as we get more and more AR devices and AR headsets, we'll see that kind of expansion in the AR space and XR space and get OpenXR across many platforms there as well. Okay, so let's talk a little bit about what's next for OpenXR. Okay, so while we have a stable OpenXR 1.0 specification, we continue to add and explore new AR and VR features through extending the core API. And this is kind of the way things work out in Khronos. And as Grace mentioned in her previous talk, we get lots of community feedback as well. So please, I have links at the end. Give us feedback about things you would like to see in OpenXR going forward to help kind of guide the development process. So when we launched in 2019, we had 16 extensions available at the time of 1.0's release. And today we have over 80 extensions now. So it's a tricky balance when you're developing a standard because you want to develop a standard to allow more and more applications across a wide variety of platforms, but you also don't want to stifle innovation on new platforms and also start exploring like, what should these new APIs look like? What's the right way to do like hand tracking, eye tracking, et cetera? So this, the extensibility of OpenXR allows companies to show off platform features that they have that maybe other platforms don't. It also allows us to experiment with what's the right way to give applications access to underlying capabilities. So let's talk about a few of the extensions, and we'll try to run through this really quickly. So we have overlays where you can overlay two-dimensional information from one application on top of an underlying 3D application running at the same time. So you can have a video conference chat while you're zooming across the universe. We also have real hand tracking. So you have joints. I forget the number of joints we have, but this represents like 4 months of work because we had a lot of different member companies that had different ways of accessing the information. So how do we unify that? How do we get what the applications are really going to need from the devices to create interesting applications? This is a really quick demo. Let's see if we have plays. Actually, we're running out of time. We can skip that. This was just going to give an example of showing off the hand tracking using library kit, using Ultraleap's API layer implementation on top of OpenXR. We also have eye tracking for eye tracking interaction for gaze interaction and also focus. We have some other eye things coming soon, which I can talk a little bit about. So this is kind of what we've been working on recently, kind of what's next. We're looking at fixing and changing a few things from 1.0, although actually we pushed really hard to get 1.0 out, and we were afraid we were going to break a lot of things. But it actually turns out things seem to have we've done a reasonably good job. We haven't had to go back and repair a lot of things. But some of the other features we're looking at is expanding support for AR and MR around scene understanding. And we're also looking at a lot of input and output capabilities around full body tracking, haptics support, and also different controllers and devices. As Grace mentioned, we're also looking at things. One of the key parts of OpenXR is our input mechanism capabilities. It allows for a lot of different devices and mix and match devices. You can also change the mapping of controllers. So if you want transport to be a particular control, whereas the game was built with fire or transport being on a different control, you can change that. So people with different accessibility concerns can interact with your applications without the application having to have this stuff built in. And as I mentioned, we already saw a real example with Vario, but one of the cool things about OpenXR is you can build your application to OpenXR, and it can run across the network to an edge server. So you can have a lightweight AR device, have the rendering being done by an edge server off in the cloud, and serve up those frames to the application. And your application doesn't need to know whether it's running natively on the headset or if it's running across the network to an edge server. So how do you get started? So here's a couple of links that you can provide us feedback. You can hit us up on our forum or through our Slack channel and give us information and feedback. And also this deck will be available after the conference, so you can take a look at this, but I'll just run through. We have lots of other resources. We have a 200-page specification, reference pages, overview guide. We have our GitHub repositories, which you can go check out under the Khronos group. We have our documentation, specification, and you can build sample code and test code. We also have a bunch of different sites provided by our member companies that give you source code and sample getting started, how to get involved with OpenXR and get your applications up and running. And with that, we could talk about the extended reality. Obviously, OpenXR is key to building on the metaverse and where VR is going. But overall, OpenXR is a win-win for everybody. End users can buy devices and know that these OpenXR applications will run on their device. Device manufacturers will know that if they supply OpenXR drivers, lots of applications will be enabled on their devices. And then as you developers build applications and use OpenXR, you know that the end users are going to be able to buy devices that can take advantage of your applications. So with that, I think we're ready to take questions. Great, thank you.
There's a couple of mics, stand-up mics, or I can bring the mic to you. Anybody have a question?
Hello, can you hear me okay? Okay, thanks. So I'm a Unity developer, and I just recently found out about OpenXR. But a lot of tutorials are pre-OpenXR. So I'm just wondering what you have to say about what packages this is going to make obsolete. I know like the platform-specific ones, it kind of does, as these companies continue to make the transition to create these OpenXR drivers. But yeah, just looking forward into the future, how do you see this changing best practices of Unity development to, I guess, just make your application as accessible to most people?
Sure. So what I would say is, well, Unity, as I mentioned, is one of the game engines that utilizes OpenXR. So I'd say just making sure as you're building your Unity applications or Unreal applications or Godot, you're using the underlying OpenXR framework. So I think there's tick boxes something where you would enable OpenXR. As far as what particular packages potentially would be obsolete, it's hard to know because they may decide, hopefully they all decide that OpenXR is the way forward, and they'll move their packages forward to utilize OpenXR, like MRTK3 was mentioned in the previous talk, utilizing OpenXR. So yeah, I'd say, and the other advice, if you're using packages and they need to use OpenXR and you want forward compatibility, then talk to their dev teams and provide them feedback to say, hey, you need to be on OpenXR if you want me to develop on your package and be deployed on all these different devices.
Great, thanks.
Any other questions?
And we can both be outside too as well. Well, I guess there's no other talk, so we don't have to rush. Unless you want to get to the party.
Yeah, this is probably a newbie question. I'm new to the OpenXR. My best understanding is OpenXR just set up API, right? And my specific question is, how is that in relation to like Unity and Unreal Engine? Was the API typical people you implement on top of those engine to implement those API, or those engine actually turn around using those APIs to implement some of the features and export to apps? So I'm still a little bit...
Sure, yeah, so in general, the game engines are a much higher level, right? They provide a lot more capabilities, a lot more abstraction layers, and OpenXR is a layer underneath. And so many of the game engines will utilize OpenXR to enable the applications. So things like the game engines and also the web browsers, as I mentioned, all use OpenXR underneath. So if you're developing a game and you don't want to learn all about OpenXR, you don't have to get all the benefits of OpenXR underneath. But if you want to build your own, you're a developer and you want all the control that you need to build your new application or new XR experience, then you can also just program directly to OpenXR and avoid having to go through Unity or Unreal or Godot.
Got it. So it usually should be the platform developer, the hardware OEM implement the OpenXR.
So they implement the drivers, but the applications actually use, because of an application programming interface, it's the application's way of talking to the underlying devices. So the devices provide the drivers, and then the application will talk through those API calls to get the information out of the device, such as where is the head, what buttons are being pressed, where are the hands.
Oh, so there's a middle layer actually implement that code based on those drivers. They implement an API that's provided by Khronos. Am I right or not?
So there's not a middle layer. That's the drivers provided by the devices actually provide that information through those API calls. So you can actually say, hey, where's the head? The application says, hey, where's the head? That call goes in the device. The device says the head is here, located in three-dimensional space.
Got it. Okay, thanks.
All right, thank you. Let's give them a round of applause.